Ever wonder why tech giants and governments are pouring billions into building quantum computers? It's not just for faster processing. A huge part of the reason is an algorithm so powerful it could break the very foundation of our digital security. It's called Shor's algorithm. And today, we're going to understand how it works without a single line of complex math. Right now, almost everything you do online, from sending an email to buying something with a credit card, is protected by encryption. This encryption relies on a simple yet incredibly difficult mathematical problem, factoring large numbers. Imagine I give you the number 15 and ask you to find the two prime numbers that multiply to get it. You'd quickly say 3 and 5. Easy, right? Now, what if I gave you a number that's hundreds of digits long? Asking a classical computer, even a supercomputer, to find its prime factors could take an impossibly long time. We're talking longer than the current age of the universe. This difficulty is the lock that keeps our digital information safe. This is where Shor's algorithm changes everything. It doesn't play by the same rules as classical computers. A classical computer would have to try cracking the code, one guess at a time. It's like trying to find a single grain of sand on an entire beach by picking them up one by one. It's a brute force approach, and it's incredibly slow. Shor's algorithm, running on a quantum computer, is much smarter. Instead of a one-by-one search, it looks for a hidden pattern within the mathematical problem itself. Think of it like this. Imagine the encryption key is hidden somewhere in a massive repeating pattern, like a wallpaper design that stretches for miles. A classical computer would have to examine every single inch of that wallpaper. A quantum computer, using Shor's algorithm, can look at the entire wallpaper pattern all at once. It uses the strange principles of quantum mechanics, like superposition and entanglement, to find the underlying rhythm or period of the pattern. It's like listening to a song. You don't need to hear every single note from start to finish to recognize the beat. You hear a snippet and your brain instantly picks up the rhythm. Shor's algorithm does something similar for numbers. It listens to the mathematical structure of the encryption and quickly identifies its repeating cycle. Once it finds this hidden pattern, this period, it can use that information to quickly calculate the prime factors of the massive number. The lock is instantly broken. The thing that would take a classical computer billions of years to solve, a sufficiently powerful quantum computer could potentially solve in just hours or minutes. This isn't science fiction from a distant future. This is applied quantum physics. And it's the primary reason why the field of cybersecurity is in a race to develop new quantum-resistant encryption methods. We are on the brink of a computational revolution where the very nature of what is possible and impossible is being redefined. The power to break modern encryption is also the power to solve other incredibly complex problems in medicine, materials, science, and more. We are truly entering a new era of computation. If you enjoyed this journey into the quantum realm and want to keep fueling your mind beyond its limits, make sure to subscribe to The Cosmic Drive. We explore the biggest ideas in science and the universe every week. Thanks for watching, and I'll see you in the next one.